Hi, good afternoon, ladies and gentlemen. Welcome to today's webinar. Today is Thursday, November 7th, our first webinar of the month. We are speaking about solar PV system testing. The subject got a lot of interest. We have over 700 registration today, and this is the first time we are speaking about solar PV system. That could be one of the reasons for good turnout. And as we continue, this must be our 285th webinar in the last 2.5 years. We've been champions of webinar on various subjects, specifically on the electrical, fire, security, automation. So it's a continuous process. This week we have almost 3 more webinars to conclude. So I want to thank those who joined on time. I'm sure we will have our expected gathering by next couple of minutes. So anyway, good afternoon once again, everyone. Thank you for joining today's important informative webinar, I would say, on solar PV testing as per IEC 60364 and IS 732 standards and IEC 62466/1. So I'm delighted to see very good response, and I could see there are a lot of professionals who are committed to enhance their understanding on solar PV system, specifically on inspection and maintenance. So today we have an international speaker who will present on the requirement for inspecting the PV installation based on these standards. So we will also talk about theoretical aspects of conducting measurement and inspections aligned with these guidelines. So our goal today is to share the knowledge not only to enhance compliance, but also ensure safety, reliability, and optimal performance of solar PV system. So we are honored to have Shyam Ravindran and Carol Kashmerek, who will guide us through these details, share their insight, and answer your queries at the end of the presentation. I hope you'll find this webinar very interesting. So my request to all the audience, please put your question answer in the Q&A box. Do not post it in the chat box. So we will not be able to record your questions in the chat box. So my humble request to post your questions in Q&A box only. And those who want to talk to the speakers can raise your hand. There is, if you look at the bar, raise your hand. And once in between the question, I'll also welcome the question, live question answer. But make sure that the questions are limited to today's subject, which is solar PV system testing. Do not put questions which is not related to today's webinar. So myself, I'm Dominic. I'm from the fire background. Founding member of FSA, Fire and Security of India, and I'm a founder member of FOCUS, Forum of Critical Utility Services, and founder member of NFE, National Federation of Engineers for Electrical Safety. So I have 4 active society which be giving back to society through this organization. With me, I have my very good friend, fantastic speaker who's been traveling with us in almost the length and breadth of the country. You may be aware that we are doing National Electrical Code of India's workshop and CA's workshop throughout the country. I think on November 15th, we are doing in Trivandrum, followed by Ranchi. So we are running length and breadth of the country, and Shyam has been partner to most of these workshops. Enlightening the subject on measurement. So testing and measurement. So I love to have Shyam giving you opening remarks. So Shyam holds a rich 15 years of experience in electrical testing and measuring in India and Europe. His educational qualifications include Master in Electrical Power Engineering from WT Poland and certified professional thermographer. He has published various technical papers, including CI Red in Sweden. That's young entrepreneur managing a very successful businessman, Sham, for you. And we have an international speaker from Poland. So he has joined us from Poland. He is Karol Kaczmarek. He is the head of training and technical support department at Sonet. With over a decade of experience in training, he specializes in electrical safety measurement, fundamentals of power quality analysis, earthing of energy devices, PV installation, and electrical vehicle charging stations. So he has delivered over 2,000 hours of lectures and workshops to electrical engineering students and professional electricians across the globe. In addition to training, he conducts inspection of low voltage installation, solar PV system, and electric vehicle charger. That's Carol for you. So I will now welcome, I'm going to unshare the screen. I'm going to welcome Sham to give his opening remark. Over to you, Sham.
Thank you, Mr. Dominic, for your kind introduction. Once my screen is there, please let me know if you can see. Can you see my screen?
Yeah, perfect. You can make it yeah. You're ready to go.
Yeah, once again, good afternoon, and thank you so much, Mr. Dominic, for this kind introduction. So, before we begin the session, I'm very excited about the session because first, it's a working day, Thursday evening, and we saw such a wonderful number of registrations, mainly from India and all across the globe, majorly from India and Middle East. Uh, it was really overwhelming, and thank you for this, interest in joining this webinar. So, good afternoon, good evening. My name is Sham Ravindran. I'm from Sonal Instruments India Private Limited. I'm the managing director of this company. I manage the operations of Sonal for India, Indian subcontinent territories. I'm joined by my colleague, Mr. Karol Kaczmarek. I hope I spelled it right, Karol. The head of technical trainings from our Poland office. I have, before I get into the technical part, I can highly recommend Karol's technical knowledge. I have seen his skill on the technical demonstrations as well as presentations, and I believe he can give some practical insights on the demonstration on all the topics, of course, but what he mentioned in his specialty. But today we will restrict to solar PV installations. But I highly admire his skill on the practical demonstrations and his technical skills in general. So thank you, Karol, for joining us for the presentation today. My session, I wanted to start my session by the interest on why solar PV is getting or the verification becomes an interesting topic for all of us. So before we move in, I just wanted to give you a quick stat on what is written from MNRE, the Ministry of New and Renewable Energy. As we saw, we have about 70.1 gigawatt been posted in the MNRE website by 2023. The other stats are also quite interesting. Solar becoming one of the most secure of all sources. Please note this is an extract copy from an MNRE website. So these are the words that is exactly used by the ministry as one of the most secure of all sources, and it is abundantly available. So this becomes a very interesting area for the country to look into for the alternative sources of their energy requirements moving forward. By looking into another stat, it's a very interesting stat because India was standing at a fifth in the solar PV deployment in 2022 from 70.1 gigawatt. And recently, the stats as of September 30th is around 90.76 gigawatt, which is about 20 gigawatts added approximately in less than 20 months. And that's the third largest producer, producing at about 1 gigawatt per month on an average scale. And the largest corporate companies who are involved in this production have much more larger visions. The government have much more larger visions as well. The plan by some corporates itself is to have a 50 gigawatt by 2030. So this is going to be a very interesting area of energy production for the next couple of years to move. So this actually marks a significant effort of India to fight against the sustainability goals on climate change. Also, when I noticed the participants from the other countries, I thought of I'll just look into the stats of the other countries. For example, UAE, an oil producing nation. What I mean by this is like the majority of their energy production comes from non-renewable energy sources. You can see from the past 1 year itself, from 4.5%, they're moving to 8.3%. The government across the Middle East has this goal of having renewable energy productions at least by 50, 70. It varies from government to government. The geopolitical issues also falls behind it. But let's not look into the stats so deeply whether they are at 10 or 15. But it is evident that this energy production is increasing much rapidly than any other forms of energy production. Looking into Bangladesh, 459 megawatt is produced from 10 solar power plants on a mix. As I was mentioning, every country wanted to have its dependency on a they do not want to depend mainly on the fossil fuel form of energy production, but they are all trying to move to a renewable or the reliable power which they wanted to have by the next years to come. So when we move at a rapid pace, there should be some kind of a guideline which we put in accordance for the verifications of these installations. As Mr. Dominic was mentioning, it is not only about the safety part, it is also about giving the consumers a reliable form of production. Yeah. So for that, there are certain standards that are put into the practice. As a IEC becomes the international standard of verification. Today's session, we will look into the standards from IEC 60364 and 62446-1. For the audience in India, there are Indian standards and the Indian standard numbers, but mostly you will be able to find these citations. If you talk about Indian market in specifically, for the AC installations on verifications, the standard numbers will be 732, 18732, which will talk about the low voltage electrical installations, part 6 and part 7, 712. The primary document will be your National Electrical Code 2023. When we move into the DC part, the last chapter in our National Electrical Code talks about the photovoltaic installations, where you will find the reference of 62446-1 for the testing, documentation, maintenance for the grid connected solar PV systems. Carol will be explaining in his session in detail about for the AC verification as well as the DC verification in his presentations. Just to give you a quick overview, my friends, about our company. This is a Poland-based company. I started in the year 1994. So we are almost like a 3-decade company this year. We are celebrating our 30th year anniversary next week. And in 2013, I created a joint venture with Sonal Poland in India. And in 2024, a 12-year-old establishment in India already, we cover Indian subcontinent, UAE, mostly all the electrical power utilities across the countries. I'm very proud to tell that, and I'm very happy to have almost all the power utilities across the country being our customers. I'm also proud to have some of the defense defense part being our customers as well. The domain of our organization works in 3 domains: testing and measuring equipments, calibration and automation. From the testing and measuring equipment point, we cover from the transmission, distribution, as well as the complete energy domain with almost 200 plus products which we manufacture. Before we get into the topic of the verification, I wanted to bring in another important standard, which is power quality standard. We didn't mention it in the title of the presentation. It's just for you, all of you, to give a heads up on power quality, because I strongly believe in today's market you can't differentiate between safety and power quality. So with all this the demands that what we received from our customers on power quality, as we know, power quality is going to be a very inevitable topic in any form of energy production, and solar PV, the moment you connect it to the grid, this is going to be a major challenge. So we with all the requirements from our customers, which demanded a modular construction, a built-in web server, TCP/IP protocol on 61850 and a PQD format, the customers demanded the continuous monitoring of power quality as a major challenge, which we have been requested over the years, which helps the generations of the reports. Now, when we talk about the standards, we are now referring to IEC as a standard. But when we talk about the regulation, every country have their own regulation. When we talk about India, CEA for connectivity to the grid, under regulation column, you will find this connectivity to the grid and connectivity of distributed energy generation resources. You will find this power quality, and the monitoring of power quality is already regulated in India for a continuous energy production, in which what I've highlighted here, you will be able to see the standards for distribution generation resources and prosumers when acting as a generator shall be substituted. So the standards which include for power quality on as per the regulatory complaints will be having a reports on IEEE 519/2014 standards as amended from time to time. Now we have even 2022 standards, but this is taken from 2019 publications. The measurement and regulation shall also comply to a continuous monitoring on Class A power quality. And this is not only mentioned, and this is mentioned in the connectivity to the grid and the connectivity to the distributed energy resources. While Carol will mention and talk about the measurement on AC verifications, you will find some measurements like RCD verifications. And in terms of a solar PV installations, it is inevitable you maintain this power quality as a continuous energy monitoring, because this goes hand in hand. I believe the importance of this power quality is emphasized before we start the presentation, and also to make it a little bit informative to all of you, we have prepared some demonstration videos in our YouTube channel. Those who are interested, please have a look into our channels. We have prepared how you are supposed to connect and how you are supposed to make measurements on a practical way in our YouTube channels. If you are interested, please have a look, and you can always write back your opinion back to us. And this marks the end of my session. As Mr. Dominic was mentioning, please try to put your questions by the end of the session, Carol session, or during the session in your Q&A session. In your Q&A box, we will collect the questions and answer the questions one by one. These are my contact details, guys. If you have any questions, you can always feel free to write back to me. So I'm going to stop my screen. Carol, over to you. Over to you, Mr. Dominic, to pass it on.
Yeah, if you're unsure, I'm welcome Carol. Carol from Poland will be on live with us. As I requested, make sure that your questions are related to today's subject, and Sham will also be there trying to answer to your questions. Over to you, Mr. Carol.
Okay, thank you, Mr. Dominic. Thank you, Sham. I share my screen. Okay, in today's webinar, we will talk about electrical measurements in PV systems. There are many technical standards related to photovoltaic installation. These standards cover equipment manufacturing, installation design, system construction, as well as initial and periodic inspection. Fortunately, for these who doing photovoltaic installation inspection, only two standards are truly important. This is IEC 60364, known as IS 732 in India, and IEC 62446 as well. So From this, the key section are part 6 of IEC 60364 and sheet 712 in part 7 of the same standard. For IEC 62446, we need to focus on part 1 and part 2. We should set the inspection intervals for photovoltaic installation based on several factors, including the recommendations of the equipment manufacturers used in the installation, such as inverters of panels. Previous inspection records should also be considered. If we are performing a periodic inspection, such documents will certainly be available. However, for an initial inspection before the installations start up, this information won't be present. The standard 62446 part 2 is also useful, recommending an annual inspection of photovoltaic installation for the first 5 years, after which the interval between inspection may be extended. Certainly, the most important factor to consider is the national regulations regarding electrical installation safety inspections. In accordance with these two standards, it is assumed that the frequency of the periodic verification for the PV system should not exceed the frequency of periodic verification for the installation to which the PV system is connected. Example, in Poland, the periodic verification is interval for a PV system connected to a residential or commercial installation is 5 years. However, if the PV system is connected to a specific risk place, such as a factory, this interval should be shorter. For example, a PV system connected to a petrol station must be checked every year. We should remember that verifying the installation is not only about taking measurements. Verification includes 3 main steps: visual inspection and papers checks, taking measurements, and preparing documentation and a report after the inspection. Visual inspection includes checking if all the system components are correctly selected and installed, and if there is no visible damage to any parts. We begin the verification of the PV system by checking the AC side first, then the DC side. We inspect the AC side in the same way as a low voltage installation following IEC 60364 part 6. In India, the standard is known as IS 732. The measurements described in the IS 732 standard, specifically clause 6, the tests include continuity testing of protecting the connections, insulation resistant testing, automatic disconnection of supply by measuring the loop impedance, additional protection testing by checking the LCD's parameter, and polarity testing. I think this 1, 2, 3, 4, 5, 6. This 6 measurements is the core of the measurements in PV system. In small PV system, if we are talking about power plant, PV power plant, the measurements will be different. I want to show you how we make the measurement of the some of these parameters. The continuity of conductors and connection shall be verified by measurement of resistance on protective conductors, exposed conductive parts. We check the continuity between the main grounding bar and the housing of the current using equipment. For example, here we have a washing machine. or the ground pin of a socket. Okay, we can check. Now we can check the continuity between the main grounding bar and the housing of the current using equipment. We can check the continuity to the pin of the socket. We can also check continuity between the grounding bar and, for example, water or gas pipe. In PV system, we will check the continuity between the grounding bar and the construction and the panels. I show you this in next steps. Insulation resistance, we can measure insulation resistance using wires or the adapters. The test can be done either by checking each wire separately or by shorting the live wires together and testing them against the protective wire. This is described in IS 732 standard, section 6233. When testing wire-to-wire insulation, you may notice that the insulation between L and N wire has a lower value, as I show you. This is the way we short-circuit live and neutral current, live and neutral wire, and check the insulation resistance to the protective wire. And now I will check the resistance between live and neutral, live and protective, and neutral and protective. If you measure insulation resistance in this way, you can see that live neutral value is less. That's why it is important to prepare the installation before measurement, because this can happen when current using equipment are connected to the circuit being tested. So if we make the measurement in the PV system, we have to check if in this installation there are no current using equipment, any other current using equipment. Next, loop impedance, protective by automatic disconnection of supply. We measure a loop impedance and check if the condition for the automatic disconnection is met. With the configuration terminals, we can show the difference between the results. Here I show you the difference between if we measure the loop impedance in the TN system and TT system, how we can check what kind of earthing system is in our installation. Sorry, I am speaking too fast. I will. Okay, now you can see we make the measure of loop impedance in TN system. First live neutral, now live protective. And as you see, the values are almost the same. The difference is very small. Now we do this on the TT system. So the difference is bigger. This is first information. If we make the measurement of loop impedance and the value of life neutral and life protective measurement is very different. It is first point we have to check if we have the TN or TT system. So next we have RCD parameter testing. In PV systems, sometimes we have RCD, sometimes we don't have RCD, but I want to show you. We measure the trip current and trip time for the rated current. So the standards don't want us to measure all the parameters of RCD. We need only check the current, trip current, and trip time for the rated current. How we can do this? Wait, measurements for current. Of course, we have to turn on the RCD. The RCD is 30 milliamps, so 25 milliamps is okay. And we measure the time for trip time for rated current, 18 milliseconds. Standard says that the maximum is 300 milliseconds. I think if you need to improve your knowledge and skills in measuring electrical shock protection in low voltage installation, the best way is to attend a workshop organized by NFE. I think about NFE and about workshop, you can definitely get more information from the NFE team. Okay, the perform measuring use devices that comply with the relevant parts of the IEC 61557 standard and have safety ensured according to the IEC 61010 standard. Sorry. We have measurements should be performed with a minimum irradiation of 400 watts per square meter. You can do measurement if there is less than 400 watts per square meter, but if you want to recount the values to the standard condition, in this situation, it will be harder. But you have to make the measurements under stable condition. So we have to do measurements in stable conditions. During the visual inspection, we should also check the system documentation. The minimum required documentation is described in the standard. So here we have what is the minimum version of the documentation. This documentation should contain information about the system, about the designer, about the installer, system description, diagrams, technical specification of devices, system operation and maintenance manual, and of course, a report on the system acceptance, verification, and commissioning. So this is the minimum documentation that every PV system should have. We have three types of tests in PV system, which tests are described in 62446 Part 1 standard. All installation, regardless of size, should be measured, should have tests category 1. So we have to make continuity of earthing on equipotential bonding conductors, polarity test, combiner box test, string open circuit voltage, string circuit current test, functional ion test, at insulation in resistance of the DC circuit. We will talk about these tests in a minute. Category 2 test, this is extended test. This, in addition of the category 5 test, the following test can also be applied. Current voltage characteristic known as EV curve and thermographic test. But this test should be made if we inspect bigger or the biggest PV systems. Additional tests include voltage to ground, blocking diode test if it is used, wet insulation test, and shade evaluating. Okay, category 1 tests we should make. Connection continuity that you showed before, but I show you a different video with this test. If the photovoltaic installation has its own grounding, the next test is to measure the grounding resistance of this system. The next test is to check the polarity. We make sure that the positive terminals are truly positive and the negative terminals are truly negative. Next test is to measure the open circuit voltage. Some meters may need an additional accessory to perform this test. For the next test, which is measuring the short circuit current, we may also need additional accessories in some cases. Only under specific condition can we check the short circuit current. By knowing the temperature and radiation levels, we can convert the measured current to standard condition. As you see here, we have the value of measure current, and here we have the value of current in standard condition. This is recalculated by the method. Insulation resistance is the final test in the system. Most measuring devices perform this test in 2 steps. First, we check the insulation resistance between the positive pole and earth, like here. First, positive to earth, then between the negative to earth. The standard describes minimum insulation resistance values, but in practice, the values we usually see are much higher than required. You see the standard, we have 1 mega ohm. Normally, we have even 1 giga ohm of the resistance. The post-inspection report should include system information and description of the visual inspection and any deviation measurement values, and it should be signed by a qualified person, of course. Okay, now I show you. We prepared for you some movies. Okay. First, of course, we need to turn off the system. Then we set up the irradiance and temperature meter. We don't see this on the film. Here is the irradiation meter. As always, we start the measurements by checking continuity. We verify that there is electrical continuity between the grounding or main grounding bar and the construction and panels. As you see, I check all panels and some of the points in construction. What point in construction we should check? You have to decide yourself when you make the visual inspection. Next, of course, we measure the open circuit voltage of the string. We have to wait. As you see, there is voltage. We have. Okay, we have voltage. This is the value of we measure. This is the value in standard condition. Next, we measure short circuit current of the string. And here you see measured current and current in standard condition. The meter recalculate the value because the meter knows what is the irradiation during the measurement. Finally, we check the insulation resistance. Most methods do this in 2 steps I said before. This method do the same. First, the meter makes the resistance between between positive pole and ground, and then between negative. You see here we have ground, positive to ground, and then negative to ground. We have to wait for start. The measure start. We wait. This meter makes measurement of resistant insulation about 15 seconds, 15 to 20 seconds. But the measure of resistance of isolation, the time of this measure, it is longer if we have more panels in our system. This system is 10 panels, so we have 3.6, 3.7 kilowatts, about 400 volts and about 11 amps. Okay, take it. Okay. As you saw, it is not very complicated to make the measurements in PV system. Now I have the question if there is any question. Sham, Mr. Dominic?
Hello, Carol, am I audible?
Okay.
Yeah.
I was afraid that nobody hear me.
We could
Sorry.
hear you. So, we have, I think, we have question answer to. I would urge all the participants, those who could follow Mr. Carol's presentation. So, if you have any questions, answer, please post it in the Q&A box down below, and we'll take it up. And those who would like to speak to the online, so just raise your hand. We will have you connected live with the speakers. So you may raise hand. So I will take up the questions a little later. Okay. Carol, hope you can understand my English from here, and I'm sure Sham is there to assist me. I'll take up the first question so quickly. This is a question from Etela. How do one can meet grid compliance in India? Sham, this related to Indian statutory requirement. Anything that we can add into this question?
Yeah, this actually it's a wide question, sir. In India, if we talk about as a grid compliance, there are few parameters which we need to look into it. One, what is the requirements from the local distribution company? Because that can also vary from different parts of India. The requirements from different utilities are also to be considered. Now, I mentioned in the beginning of my presentation one CEA guidelines documents. I highly recommend people to have a look into that guideline documents. What is the CES mandate? Because now, when the guideline comes, the standard comes from BAS. What is the regulatory statutory bodies say? The final say is also very important. So, if you go to CES website, you will find on the regulations, grid connected regulations, step by step. What are the primary requirements for someone to have a grid compliance is something that we need to look into it. And once when you connect it to the grid, the verification after installation, as what Mr. Karol was mentioning throughout his session, the periodical verification having it safe as a safe installation is also an important parameter check which the customers have to look into it. Finally, not but not the least, the manufacturers in which they have opted out. For example, which manufacturers or the which installation companies they have opted. The guidelines given by the individual manufacturers are also to be considered when they take their implementation procedures.
Okay. So the next question from Subrata Kumar Vera, is there a checklist for solar power maintenance? Do we have any standard checklist?
Karol, do you have a point here? I think the checklist are the standards, but what's your opinion?
Yeah, checklist in the standard 62446 part 2. There is many of causes what we should do with the power solar power if something happened. I don't think there is ready checklist. Every solar power company should make their own maintenance checklist.
So even to say they make their own checklist, each company make whether there's no standard checklist that is available. So
Yes,
Teju
because there
Singh,
are
yeah, go
there are
ahead, go ahead.
few components connected into the system, sir, and there are some instructions given from the manufacturers. For example, if we talk about an inverter connected into the system, the manufacturer have given some guidelines on their maintenance. So that's why the checklist can slightly modify based on the choice of the manufacturers which you choose. However, having said with all that, the verification following to the verification will be only based on the standards. So the periodical checking, what we mentioned throughout with the practical demonstration, will be how you do a measurements as the verification.
This question, I don't know, Sham, can you able to address this? Tej, I'll just read out the question. Tejwar Singh is asking, what area required for producing 1 megawatt output in
Yeah.
NCR region? This is actually question for solar companies, solar PV company.
Yeah.
But
So,
we are talking about this.
I am not able to answer to the question on vapor absorption systems. I am not very familiar about that system. But however, to produce a 1 megawatt output generally for such kind of a value, you will need somewhere between 5 to 6 acres of a land. With this, in the beginning of my presentation, sir, I mentioned a word what was written by MNRE. The production on National Institute of Solar Energy (NISE) has assessed the country's solar potential of about 748 gigawatt, assuming 3% of the wasteland to be covered by solar PV modules. So the energy production, if we talk about Delhi NCR or any capital areas, can we produce such vast area? I mean, vast power in such kind of city limits might not be an ideal solution for a country like India. We have to target the production elsewhere, keeping into the view where do we optimally require, or where do we have optimal possibility of the solar energy recipient as well. So the answer to that question technically will be about 5 to 6 acres. The only solution for NCR will be a rooftop. It can't
Okay.
be produced in a larger.
Okay, I'll take one live question. Live question is from Omer Deniz. So, is Deniz? Can you go? Can you please address the question? Omer Deniz, can
Yeah,
you hear me?
yeah, I can hear you. But actually, I've written in the question and answer window my questions. Sorry.
Okay. Okay. So, is there a function? His question is there function to measure DC potential induced on the panel? Question to Carol. Is there a function to measure DC potential induced on the panel?
We are talking about PIT problems.
Omer?
Yes,
Can you
yes, PID. I'm talking about PID.
Yes, yeah. So the answer is yes and no. Yes, because we can use many of measurements. For example, curve, IV curve can help us. Thermographic can help us. But if we are talking about the system which is on grid or which is energized, this is very, very hard to take this sort of measurements. If we don't want PIT problem in our system, we should make everything that the system will be built in properly way and with the best of the panels on the market. After that, it is very, very hard. I think you should start with EV curve and thermographic.
Okay, thank you.
Thank you. Okay, next question to Gagan. Gagan is asking, what is the highest efficiency you have measured? Shyam?
Carol, what is the highest? You're talking about Mr. Gagan, or you're talking about the inverter efficiency?
We are talking about one string, how big one string, or how big farm. If we are talking about string, is almost 20 kilowatts. We have the system now that one string has almost 20 kilowatts, but if we are talking about power plant, it is more than 17 megawatts.
Okay. The next question here, Etela, the next question is asking, in India, do we have any third-party assessor for testing the installation apart from the electrical inspector? Over to Shyam.
It's a very difficult question, sir, because here everybody is an assessor. There are many companies which do this as a professional testing, but the licensed companies or the licensed parties only are allowed to do the verifications. So if you ask the question, is there any company? Yes, please look into the verification licenses these companies do hold, who claim to have the verifications. When we talk about the products, please look into the standards, what the products are complying. Please look into the licenses, what the companies have. I can't name the companies in the public forum. It will look like I'm trying to promote someone. But yeah, there are quite a lot of companies. You can write to me privately. I've shared my contact details. I'll give you some of the companies who are involved in such kind of verifications.
Okay, next live question I'm asking Kailas. Can you unmute and put your question, please? Kailas, can you hear me? Okay, I'll go to next, Dr. Rajesh Arora. I'm asking you to speak, Dr. Rajesh Arora. Hope you can hear me.
Good evening, everyone.
Good evening, sir. How are you, sir?
I'm fine, and as usual, wonderful presentation and good moderation from your side. My query
Thank you,
is
sir.
related to the one product. There are three parts of your solar system: AC side, DC side, and then the inverter. You have talked about testings of AC side, DC side, but at the same time, we have to do some testing for inverter also. That was missing. And secondly, apart from continuity testing, earthing testing, there is testings of efficiency of your overall system. That was not mentioned in your presentation. That is also mandated to perform at site. And apart from that, you have to check the DC cables. You have to check proper bonding, earthing, and you have to ensure overall safety of your PV system. And you have depicted all these things very well. But my suggestion is include the testings of inverter also for the further presentations.
Sure, sir. Well noted. For inverter, we have the possibility to measure the inverter efficiency as well, but we couldn't share it here because it was not specifically mentioned in 62446. However, yes, we can make the inverter efficiency measurements. Carol, do
And
you want to add some comments here?
No,
Carol?
no, yeah, I'm here. No, you said everything about this.
Yes. Yes, sir. Please, if you have any further questions, sir. But your points are well
uh,
noted, sir.
and further suggestion is that when you talk about the testings required, there are some specific testings as per PM Surya Yojana. MNRE has given some guidelines and they have specified some IES and IC to be followed for during commissioning, after commissioning, for the condition monitoring of the PV system. All these things must be included in your presentation, and we have to make people aware about that thing also, so that the dream of having 500 gigawatt by 2023, 2030, and COP26 promises to be fulfilled.
Okay. The points are well taken, sir. I think this feedback we will definitely give it to Carol and Sham. I think next series probably we can include. Thank you so
Thank
much,
you.
sir. Thank you so much for joining us, and your presence is very well appreciated. Thank you very much, sir. Okay, let's move to the next question. Gagan is asking: Is your system is suitable for all format of solar PV fully, semi-tinted and rollable, flexible solar PV panels? For you, Shyam, to answer.
Yeah, Carol, I would request you to please answer to this question. But of course, this is the similar one. But Carol, your opinion, please. The question from Mr. Gagan: Is your system suitable for all formats of solar PV, fully semi-tinted?
Yes, we can. Yes, we can measure all the systems, all the panels as well. There is no problem to make the measurements in any panels,
Yes.
but we have to remember that the meters should have voltage and current. So if we want to measure, there will be the problem if, for example, panels gives us I don't know, 12 volts. We can't measure that values. Our meters should have minimum 18 volts, maximum 1000 on 1500,000. Sorry, or 1500.
Yes.
Okay, moving to the next question. Saheli Sen Gupta is asking: What is the voltage and current range
Yeah.
of PDM 1020?
Okay, this is a model from our product range. PVM 1020 is a 1000 volt and a 20 ampere. For a 1500 volt, it is PVM 1530, which operates for 1500 volt and a 30 ampere system.
Okay. Omer is asking: Would you brief about IEC standards again for large solar power plants? IEC standard for large solar power plants.
Carol, can you please add some more insights for the large solar farm?
For For big systems, we have to make first category tests and second category tests. So we have to make the curve, and after energize the system, we have to make the thermographic. The additional tests is when we have some issues on our system and we don't know what these issues are. So small systems, only first category. If we have a big system, we have to make tests from second category too.
Okay, hope Omer, you got the answer there. Dinesh is asking, what is the recommend procedure for earthing system for PV system? Karan, what is the recommended procedure for earthing system in PV system?
I think this question is for projectants who should project the grounding system for photovoltaic system. Or
Yeah, this is addressed to the project companies, but according to you, which system do you recommend from the standard perspective for the PV system? What kind of a thing do you recommend?
sorry, but I don't recommend nothing. Because if you make the system, you should have the project. If you don't have the project,
Yeah.
you should take the standards and you should think about the earthing system. I don't like to tell about this because sorry guys, if you make something improperly, I said how to make it. You do this, but in this situation you have, it will not be okay. It might be problem. I think you should take the projectants and project and make the grounding system like in project is.
Noted. The next question is for large PV plant, is it recommend to test each string or random sampling test cell shall suffice? If per string test, that's a lot. What's your answer?
Yeah, that's right. We have to test each string in this system. Sorry, but if you want to test big PV plant, you have to has 2 months and 50 people to make it.
Yeah.
And that's all.
Yeah.
Okay. This question,
next-
take up Shyam.
Yeah, I think hotspot is not easily visible in the cell. Any method to identify the spot other than thermal image. So practically speaking, a good thermal imager, what I mean by a good thermal imager is the thermal imager which has a better resolution can help here. I'm slightly confident with what I say here because we operated such kind of installations with good resolution cameras, and we are able to identify the hotspots. Now, when we look into the standard perspective, there are two ways to look into it. The IEC standard recommends you to go for a thermal image, but it doesn't recommend which resolution or what resolution of a thermal imaging camera should it be. Now, if you go for an Indian BIS standard, for thermal imaging inspection, again, it will be 16.16.8. That is a standard for guideline or infrared thermography inspection and electrical installation. But that doesn't correlate directly what is the resolution or the recommendation for the solar PV applications. I would personally recommend a good resolution thermal imaging cameras. A minimum of a 320 to 240 is the resolution which will be mentioned in any manufacturer's data sheets. Should help in identifying the hotspot in the cell. Carol, do you have any other comments to add? What do you have any other comments other than a thermal image? How do you identify in this?
EV curve can help,
Yeah, yeah,
but for if we talking about thermal image in PV system, there is a
yeah,
standard. It's not official standard. IEC 62446 part 3.
yeah,
This is part, it is IECTS. So it is not standard published as standard. It is only technical recommendation.
yeah,
So we can, for now, we can use it. But if there is biggest problem, not only one spot, but biggest problem, we can use, as I said, EV curve. And I don't see any other ways if thermal image for the spot.
yeah. The mixer, we can go to the next question.
Yeah.
Carol, the question is, as per my personal observation of solar panel positioning is based on a bulk as per site condition, whereas in practice, the total irradiation power cannot be utilized because of wrong installation and wrong abling of the strings. Is there any issue to make conforming compared to surface irradiation capacity and existing power generated? Carol?
Yeah. Directly, no, but we
Yeah.
can make the analyzing of the power on the AC side, and in this the same time we have to check the irradiation. So when we put these values together, we will see if our system works properly or if our system has the max power it can have. This is the big problem in whole the world, not only in India, that the system is make I don't have a nice word for this, what some companies make with our money when they make the PV system. It is not, we don't have ready, we don't have 1 method to make this tests. You can put the power analyzer and irradiation meter and check if the same and check if this system have enough power.
Joel is asking, could you could describe about Topocon N-type panel? Heard that the degradation is very high. Is it correct comparing with P types? I think this is not related to trace subjects. I'm skipping. How many solar panel are required to produce? So this is again unrelated. Gagan, are you working on developing a solar panel? No.
No.
Sahil, how to identify defective modules in a string, and also amount of defects of occurrence of each module? Would you like to answer that?
Carol, would you like to answer the question from Mr. Saheli Sengupta? How do you identify the defective modules in a string?
The same EV
Yes.
curve, or we have to check every panel separately. So if we have many time, we can all the panels disconnect and check which panel is have error, or we have use EV curve and we will see which panel with which panel is the problem?
Okay.
I think I have
Uh,
Pravesh Bairagi, who's online now. Sir, please raise your questions.
Yeah, actually, I just want to answer one of the question raised that regarding the earthing of the PV module system.
Mhm.
So I would like to answer here is that in India, for most of the small PV module plants, earthing was just put on the standard basis. Three earthing for one is for DC, one is for AC side, and one is for body or LA. So this is being followed, but this way is wrong. For big plants, proper earthing is being followed after measuring soil resistivity and after designing the proper earthing. So this is the lacuna area. This is the gap where earthing is not being followed properly in PV modules, mostly for small plants or for domestic plants.
Thanks for assisting us with the answer, sir. Thank you very much.
Thank you, sir. Thank you.
Sanjay Mule, you have, can I ask you to unmute?
Yeah,
Yeah.
yeah. Good evening, guys. See, I have executed the solar PV project at one of my site, which is of 500 kWp capacity. And what I faced is that the harmonics are huge, and that is impacting on the power factor at the grid side. So we have to go. Then we have not commissioned the whole plant, but then we did modification. We did put the active harmonic filters in the system, and then our power factor maintained as per this one. Now a question, or rather question, I want to ask Sham or to Carol, saying that okay, yes, I know that is there an equipment of Sonal where we can monitor the understand or check the harmonics generation, because I had long technical arguments with the supplier of system PV system, because they said the inverter, it is properly giving, it is not generating harmonics, but when injected in the my system, I started facing this problem. Otherwise, independently, I didn't have any power factor issue. And when we analyzed that, we thought, okay, then ultimately we got solution of active harmonic filter. So, question to Sham, okay, have you faced such issues, or when we do we have measurement wherein we can understand, okay, harmonic generation is within limit as per IEEE guidelines and all the things? Sham?
Agreed, sir. Thank you for bringing this question also. In my presentation, I have shared the need of power quality.
Yes.
Even in fact, the topic today was about the verification of a solar PV installations. As you rightly pointed out, sir, power quality or power quality related issues, yes, I have seen it in quite few installations, and that is a reason I have got that in topic itself in my slide. Now, when we talk about a PQ or anything related to a PQ issues, uh, there will be always a debate where or what is the source of a power quality that we are having as an impact. That is where the CEA guideline comes in very handy, sir. We are supposed to have, irrespective of the manufacturer, irrespective of the tool that you utilize, the tool, the product, what I mean by the power quality product, should be a fully complied Class A equipment. The moment I say it is a fully complied Class A equipment means a manufacturer who is supplying the product, whatever will be the product, I'm not defining that. In some instances it can be an inverter manufacturer, in some instances, for example, it could be from the load side, because we have quite a few lot of customers who are having their own solar power generated from their facility, also having the power produced, produced from solar, and also consuming power from the distribution company. So in whatever will be the site conditions, the assessment of power quality using a fully compliant Class A equipment is is mandatory. If I read the words and from the CEA guideline, it is required for a continuous monitoring of power quality. Why? Because now we are having a lot of grid stability issues, wherein monitoring of power quality or power quality related parameters continuously is inevitable. Now, if someone will say, this is not from me, or if I do not accept to the value, for example, in your instances, sir, you are saying that I have monitored harmonic issues or any other power quality issues. How do you define that? That is where the standard comes in handy. 61004-30, continuous monitoring of power quality. Reporting shall be in IEEE 519/2022.
Yes, yes,
If these two conditions are met, this is written in the CA guideline document as well. If these two conditions are met, and if you submit this document, then the next question will be what is the direction, whether it is from the load side, whether it is from the
yeah.
manufacturer side. Then we address the next topic. That's the procedure of working into power quality issues, sir. So I have heard about these issues from almost most of our customers. That is why I
Yes.
took this topic also. And also, having said that, in Carol's presentation, he mentioned about 60364, wherein there is a automatic disconnection of supply. An automatic
Mhm.
disconnection of supply is a quite a vast topic, in fact, in which there are two kind of protected devices in AC installation. We are talking about whether it is an MCB or MCCB or your RCD. Okay,
Mm.
what type of RCD you are using in your installation is usually recommended by, in some instances, by the manufacturers as well. And in case if the wrong rating of the protected devices are used, it's basically of no use at all. Here, the
Yeah.
power quality will join hands with safety. So that is the reason I've mentioned in my presentation that you can't take out power quality in today's scenario with safety.
Yeah, I do agree, Sham, that
Yes, sir.
yes, we did this PQ and then we come to know this is the issue, and then we put AHF, active harmonic
Yes.
filter, in the system, and then a problem got solved. That is
Yes.
what, and still I'm no. This is not only I have experience, but when I visited other sites also, they
Yes.
said, yeah, this is what we are suffering, and we put harmonic filters. Some consultant has given this issue, this advice, and we put it, and it has the problem is
Yes.
sorted. That is what it is there. Yeah,
There
absolutely.
are two or three major important points which we in power quality related issues will be there, sir. One is obviously harmonics, which you have addressed using a filters. And other parameters could be, for example, an unbalance, which is also a very common factor,
Yeah, absolutely.
voltage unbalance,
Mhm.
and related to the wrong type of RCDs, if in case that is used, that could be another important issues, or a transient related issue. A transient related issues are very typical, or it's not that easy to be resolved. But measuring of transients and understanding what is the transient level that is going in the facility is very important, and I'm sure you will agree to this
Yeah.
particular point.
Yes,
So
yes, yes.
Okay.
these are some of the factors.
Thank you.
Okay. Let's move to Emmanuel. Are you there? Can you unmute your mic? Waribuchi Emmanuel. So, okay, go ahead.
Hello,
Emmanuel,
hello,
yeah,
good morning.
good morning.
So, I actually do not have much question, but just to commend you people. And secondly, it's over there in India, but we in the tropical region, like in Africa, Nigeria particularly. I want to know what Sonia's plan is for Africa. What is Sonia's plan for
Okay.
Africa? And
Yeah, I think Sham will get back. I think he's reaching out to Africa very soon. That's what he's expanding to Middle East and Africa. So this interest of yours will be taken care by Sham later. He will email you, or he will probably talk to you, Emmanuel. Thank you so much.
thank
Thank
you,
you
sir,
so
Mr.
much for
Dominic.
joining. So
Thank
can
you.
I go to Arun? Arun, can you hear me? If you can unmute and speak. Okay, I'll take up the Rajesh Arora sir. Is there any question that you want to continue asking, or you raise a hand, so I thought you may have a question to ask.
Sir, I don't have any question. I just wanted to answer that has already been answered. How to deal with the earthing of solar PV? And as per the recommendation, very rightly said, we do earthing of DC side, AC side, and lighting protection. We don't measure the resistivity. That is only as per the recommendation of guideline given by government. But actually, that should be based on proper designing, based on the resistivity measurement. We have to do it proper designing. That is missing, but that has already been answered. And secondly, that harmonic part, we have to have good inverter that should not generate any harmonics, and that harmonics control should be there within as a inbuilt part of inverter if possible, so that there should not be any extra filters required as mentioned by Sanjay ji recently they have done for their project. And we have to do the thoroughly study for the big plant so that there should not be any harmonic generation. We have to take care of the power quality safety as well. That is mandatory.
Yes, sir.
Thank you. Thank you, sir. Thanks for
Thank you, sir.
recommendations. Last question for the day. Ashwin Kumar is asking at what time thermography testing is recommended? Sham.
I will leave this question to Mr. Karol. Yeah. Karol, do you have any recommendation on the time of thermography testing?
What we are talking, what
I mean,
what mean
the test-
time? I don't know what mean time. What time or what time in the day or what time? I don't.
I believe the question could be, for example, how often, let's address maybe in that way. How
Okay.
often are you supposed to do a thermography testing?
Okay, so it depends how often the owner of the system wants to make the thermography. Some of the PV systems has one per year. Sometimes it's one per 2 years. We should often make the catalog of the tests and at the terms and times when these tests are made. Good.
Okay.
Bye.
Okay. I think we are reaching 1.5 hours. It was quite informative. For first time, we are trying to touch upon testing and maintenance of solar PV installation. So I want to thank Carol. It must be, I don't know what is the time now. What's the time, Carol, there? Back in Poland?
1 p.m.
Oh, it's 1 p.m. It's the lunch time for you. Sorry to hold you for your lunch. It's the evening time in India. It's 5:26 p.m. I want to thank all the participants for joining this session. Someone said, is it a promotion of solar as on the sonal PV? Let me clarify that in the open forum. You are aware that NEC, National Federation of India for Electrical Safety, is crisscrossing the country in propagating the use of new national electrical code and also CA regulations. So for us to move around the country, we wanted companies to come and forward and sponsor those workshops. So Sonal has been, Sonal and of course Fluke have been coming with us for all the workshops. They're investing in sponsoring our workshop. So in return, we promised everybody, whether it is Siemens, whether it's Polycab, those who are sponsoring large amount for our workshops across the country, we have promised to introduce their product in the webinar. So the today's session and maybe in a couple of more webinars for Sonal will be given because they are invested hugely on our workshops that is going through the country. So soon we'll have Siemens talking about AFDD, and we have Polycab talking about low smoke fire. Then we have Copper Association also. So all those people who have been with us generously supporting NFE and the workshop of BAS we are offering this platform to reach out to all those almost 23,000 people who attended to talk to our sponsors. So that's the reason we are supporting all those who sponsor and those who are interested to sponsor our various program, which is educational. We are a non-profit organization, so we encourage manufacturer to come forward and keep sponsoring. So I want to once again thank Sonal and Sonal management for supporting us and walking through us to ensure that electrical safety reaches everything. Like Dr. Rajesh Arora is also very passionate about electrical safety. We are committed to make electrical safe India. So it's a mission that each individual have taken in their capacity. So I want to thank Sonal for supporting us, and I want to thank Sham and Carol for joining today's program. I look forward to see you again. Wonderful. Have a great weekend. And we have tomorrow, we have a very interesting webinar, how safe our medical institutions. So we are talking about security and safety in hospital. It's a different subject than today. And that's on tomorrow. Then we have how fast you can detect the fire and the smoke. That is on Saturday. We have a webinar on advancement on smoke detection, fire detection. So that will be on Saturday. So we have tomorrow and Saturday. A very interesting subject coming to you. Till then, have a wonderful weekend. Look forward to see you again tomorrow. Thank you. God bless you.